Okay, this tutorial is going to focus on this Spearman Rank past paper question. I'm going to respond mainly to questions 3A, C, and D, with a brief reference to question E in the context of the type of material you'd be looking to write in this knowledge-based question. So for Spearman Rank, you're more than typically likely to be asked for a null hypothesis as a one-mark question. Spearman Rank is a statistical test that's looking for a relationship or the degree of correlation between two variables. And a null hypothesis is always where you state there is no statistically significant relationship. So the only thing you then need to know is what are the two variables that you're being asked about. So let's just have a little look at supplementary item E to judge what it is. So we are told about the water pumped from mean sea level aquifers in millions of cubic meters and the salinity of that water. So we've got the pumped water, so how much water they're having to pump across a period of time that we can see in 2-year intervals. And we can see here's the water salinity, that's the amount of salt in the water over that period of time. So clearly we're wanting to see if there is some kind of relationship between the amount of water being pumped. In this case, we're looking at Malta, on the island of Malta. And is it causing the water salinity to increase? Is there some kind of relationship between the amount that's being pumped and the water salinity? So if it's a null hypothesis, we would start by saying, and I would at this point suggest that you pause the video and try to write an answer to this along with the other questions C and D especially before you listen to the actual answer. So question A, there is no statistically significant relationship between the pumped water in millions of cubic meters and the water salinity in parts per million. Okay, so there's no statistically significant relationship between those two. Right, we are then told that there's a result of looking at these two is actually plus 0.92. That's once the Spearman Rank has been conducted. As we can see, once the full Spearman Rank was completed, the result was plus 0.92. So what does that mean? State the result in terms of the null hypothesis. Well, first of all, before we even look at the critical values, we can state that it is a very strong positive relationship, and that is because the result was plus 0.92, which is very close to 1. And that's why it's not just positive, but it's also strong. However, is it statistically significant? Well, when we compare this to the table of critical values for an n of 14, we find that that plus 0.92 is indeed greater than the critical significance level of 0.99, for 0.716. So our value of 0.92 is higher than that. Therefore, we can reject the null hypothesis with a significance of 99%, which means we are 99% certain that there is a statistically significant relationship between the amount of water pumped and the water salinity. Okay, so that is our result. So is this a suitable technique for measuring correlation of two variables? Well, yes, it is, because it is a statistical technique used to measure the level of significance of relationship between two variables, and therefore Spearman Rank does show it. We also have an n, appropriately sized n of 14, so it's far above the minimum requirement of at least 8 values that we'd be looking for to do this type of test, which means that it is suitable. However, we probably should have used a Pearson's test, because both of our bits of data are actually interval, so they're both counts, actual data, and therefore Pearson's test would have been more suitable because it accounts for variation within a data set, and it doesn't turn the data into ranks, as we can see has happened here in order to calculate the Spearman Rank. So Pearson would have been more appropriate to get a better sense of whether these two variables are statistically related to each other. Now, just on the final question, which is a knowledge-based question, this is quite high. This is quite an old past paper question. And normally you'd only see up to about 5 or 6 for this. But the question focuses on the way in which continuing extraction of water is going to impact the environment, the people, and the economy of Malta. So clearly they are extracting high amounts of water, but the water is becoming more saline. So what sort of effects will an increasing amount of water pumping start to have if the water is becoming increasingly salty? Well, that's clearly going to affect people's drinking water and the quality of their drinking water. It might influence industry and whether it can continue to use water, whether industries are going to be able to locate in Malta or not, because if the water's becoming salty, that's going to be an issue. We might see the need to start rationing water more on this island. Saltier water is going to affect ecosystems that can't grow in saltier environments, so you're going to see a change in biodiversity of species. Agriculture is going to be affected because it's requiring fresh water, and the types of things that Maltese can grow is going to be impacted. Whether people can have their own swimming pools and other things, whether they need some kind of home devices to take the salt out of the water, which is going to increase the cost of living for people because there's going to be increased costs for that. They're going to need to build more desalination on the island to turn seawater into water, fresh water, but that's going to cost a lot of money, and it uses a lot of fossil fuels to desalinize water. So lots of things you could write about in response to this last question. But it is a knowledge-based question, and with advanced higher knowledge-based questions just requiring you thinking logically about the particular situation and then applying a reasonable geographic answer to your points.